Good morning. Probability lesson 4. Okay, lots of thinking on this today. Nothing new. You're still using mean, median, and mode. So let's do a quick review. Mean also means average. It's what you think of when you talk about like a baseball player's hitting average, or your average of your grade in your class, your final mark, right? This is the most commonly used measure of central tendency, and it's usually, if the data is good, the best measure for finding where in the middle you are. So to find the mean, we add up all the data and then divide by the number of pieces of data. Okay? Median, we take all of our data. Median is the middle number. Middle number. Okay? So I take my data 1, 2, 3, 4, 5. I put it in order from least to greatest. Feeling moves you to put it from greatest to least, that's fine too, but generally we do it like this. And then you find the middle number. In this case, 3 is in the middle. If it was 1, 2, 3, 4, 5, 6, we wouldn't have a number in the middle. So we would take the 2 middle numbers and figure out what is halfway between them. So what's between 3 and 4? 3.5. Okay, that's how you figure out the median. The mode is the easiest of all of them. Mode equals the most common data. So if I have 1, 2, 2, 2, 3, 4, the mode is 2 because it occurs 3 times. Okay? So there's your quick review on mean, median, and mode. Okay, question 1. You're going on a trip during March break. Not this March break. What kind of clothes should you pack? So remember that. We're thinking about what kind of clothes you should pack. The chart shows the highest daily temperatures at your destination during March break. So they've given you 15 days. The temperature ranges from 2, which is like just above freezing, to 23, which is a pretty nice hot sunny day. So find the mean, median, and mode. Oh, and the range. Okay? So to do the range, we have to take the highest piece of data, the largest value data, and subtract the smallest. So on the first, it's 23, and I don't see anything above that, so it's 23. And the lowest is 2 on day 9. So I'm going to take 2 away, and that means there's a 21-degree range. That's a huge difference. It's the difference between winter and summer. Okay, mean. You guys are going to figure this one out on your own. You're going to add up those 15 numbers, take the total, divide it by 15. That gives you your mean. If it comes out to a decimal, you're going to round it to the first decimal place. Okay, so if it's like 25.67, the 7 says the 6 round up, and it's 25.7. Okay, so things coming back together about our rounding. So you figure out the mean. The median, you're going to have to put all the data in order from smallest to biggest. So start 2, 2, 5, 7, 8, and keep going. As you're doing it, cross out the numbers you've used, or at least count at the end and make sure you have 15. Okay? When you have your data all in order, you're going to walk your fingers in until you find the number in the dead center of that 15, right? I believe it's going to be the 8th number because that would give us 7 below and 7 above. So that's your median, and your mode is, once you have everything in order, you'll be easily able to tell which piece of data repeats more often than others. That will be your mode. Okay, pause the video, go answer question 1, part A. Part B, what does the range of temperatures tell you should pack? Well, as I said before, a 21-degree swing is huge. It's the difference between what you're gonna wear in November and what you're gonna wear in like June. So there's a huge difference there. So do you only have, does it say you can only bring one type of clothing? No. So what do you think you need to bring to be warm enough for 2 and cool enough for 23? Okay, go answer that. Part C. If you looked only at the mode of the temperatures, what mistake might you make in your packing? So you're gonna have to go back, look at what the most frequently occurring piece of data was. Is it hot, warm, cool? If you only looked at that measure of central tendency, if you only looked at mode, what mistake would you make? If the mode is very low, then you wouldn't have enough cool clothes. If the mode is high, you're not going to be dressed warmly enough for the times when it's not that temperature. Okay? Pause the video, go answer that. Okay, number 2. In a company there are 20 employees. All right, 20 employees. That seems important. 20. One person has a salary of $200,000. 2 people have salaries of $75,000. All of the rest have salaries of $17,500. Okay, so there were 20 total. 2 here, 1 here makes 3, so all the rest is 17. So 17 of them make 17,500. Okay. Part A, what is the mean salary? Okay, so 1 times 200,000 is 200,000. 2 times 75,000 is 150,000. 17 times 17,500 is going to require a calculator. I'm good, but not that good. So you need to figure out what 17 times 17,500 is. Okay? Then you're going to add all of those up, 200,000, 115,000, and whatever this is. You're going to get a huge total. That's the salary for the whole company for the year, right? You need to, now it looks like we only have 3 pieces of data, but we don't. We have 20 pieces of data. It's just that we're multiplying first. So whatever total you get for everything, you are going to divide it by 20, because that's how many people there were, okay? So pause the video, go figure out the mean salary. A salary means how much somebody gets paid for a year's work, okay? It's not based on hours. Okay, part B, what is the median salary? So again, you're gonna take, now, you can do this, but you don't really need to if you just think about it for a second. To figure out the median, I have to line up all the data points, right? And then walk my fingers in and get the middle. However, there are 17 of one number. So do you think that maybe the 3 that are gonna fall on this end over here, they're nowhere near the 17 that are gonna be down here. So the median's gonna fall in the 17,500. C, what is the mode? Clearly, the data that repeats the most is, you know. Okay, D, which better reflects the salaries in the company, the mean or the mode? Well, the mean, remember, we've got a whole bunch of data points at 17,500, but we have 200,000, and 2 at 150,000, right? These 3 big ones are gonna drag the mean way up because they're so much higher than the 17,500. Now, I'll probably get the heck for saying this, but should there be 3 people making $350,000 between them when 17 people are only making $17,500? $17,500 is not a lot of money, but whatever. That's not math. That's just me thinking about the world and the way things should be. Okay, so for our mean, it's going to be significantly greater than 17,500. But the mode, which is the most frequently occurring, is 17,500. So it says, what better reflects the salaries in the company? So if you were applying for a job and it said that the average salary in our company is $40,000 or whatever it is, you go, yeah, I want to make $40,000. And then you get a job and undoubtedly you are not being hired for the $200,000 job. So you're going to be eager to take a job where you are expecting a salary in the range of $40,000, and that will be a rude awakening when you find out that you'll be making half of that. So the mean is not a good measure of the salaries in the company. The mode is a much better measure. Okay, so on to number 3. In a company, there are 20 employees. All right, so we're doing the same thing again. So I'm going to keep my 20 up here, just so I know that I'm going to have 20 pieces of data. One person has a salary of $300,000. So one earns $300,000. 2 earns $70,000. The rest have salaries ranging from $17,000 to $20,000. So $17,000 to $20,000. And this is the rest. So 17, again, 2 and 3. So I know that 17 have a salary between $17,000 and $20,000 with no 2 salaries the same. Okay, so everybody makes something different. Is there enough information to find the mean salary? No, there's not, because I have to have all, it's not good enough to say that they make something in here, and there are 3,000 different choices in between 17,000 and 20,000 for how much they could make. So I'm not going to hit the 17 that are truly their salaries. So no, you can't find the mean. Can you find the median? No, you can't, because we don't have the data values to line up from largest to smallest. Can you find the mode of the salaries? Yes, I can find the mode of the salaries, because it says that one person has a salary of $300,000, 2 earns 70, 1 earns 45. Oh, I missed the 1 earns 45. Okay. And the rest have different salaries, 17 to 20. So in the rest, there are none with the same salaries. Only 1 makes $300,000. Only 1 earns $45,000. So this is our mode, the 2 at $70,000. So we can figure out the mode. And can I figure out the range? Yes, I can figure out the range. I know who makes the most, and I know that what the absolute least could possibly be. So I know the mode, or the range, pardon me. All right, so mean, median, mode, and range. Answered all of that. Part B, which of the mean, median, and mode best reflects the salaries in the company? So again, we're going to have the same problem here. A whole bunch, the vast majority of the company makes crap money. So they are gonna, this is the best, like the best indicator of how much they make is in this pocket. These guys are the big wigs up top. So they're gonna drag the mean up. The mean is not a good choice for the, to find to reflect the salaries in the company. So the median, I think, when we have them all lined up, right? So we've got 17,000 down here and 300,000 over here, and then say 17,001. I don't know what it's going to be, but that would be the next lowest salary you could have. And the next one up here would be 70,000. That's a huge difference between 300 and 70. Then say we had 1,702 here, or 17,002, and over here we have the 45,000. And then we have 17,003, and 45,000. Now we have accommodated all of the high-paying salaries, right? Well, the median is going to cancel out all this stuff on both ends and just find the middle. So I believe the median is the best measure to reflect the salaries, because no two salaries are the same, so we can't use the mode. We don't have all the information for the mean, but even if we did, it wouldn't be accurate because this would drag it down or drag it up. But the median would find right in the middle of that huge list of 20 salaries. So you'd have as many above and as many below. So by getting rid of these outliers, they're called, we can find the true middle easier. Okay, so go answer those questions, come back for number 4. You work at a clothing store and your manager says that every week you need to hit an average daily sales of at least $500. Okay, what kind of average do you think your manager is talking about? A mean, a mode, or a median? Okay, so when he says that you need to figure out the average daily sales per week, okay? So they're figuring out you need to do $500 on average a day. So do you think he's talking about mode, where you need to hit exactly $500 most of the time? No, that makes no sense. Why, what if you made 501? That wouldn't be good? I think it'd be great. You'd make more than your sales quota. So it's not the mode. The median, lining up your 7 days and then finding in the middle, well, that's not very accurate either, because you might have some great days and some crap days, and it's not as accurate as it could be. However, when you find the mean, think about this. When do most people go shopping, right? The weekend. The weekend is by far the busiest time. So you're going to have days like maybe a Monday where Monday's not so great, but Saturday was awesome. So they're looking for an average of $500 a day. So you can take some money from Saturday and give it to Monday so that you average out $500 a day. A better way, a better way to say it might be that 500 times 7 is 3,500, right? A better way to say it might be that we want to hit 3,500 for the week, right? So that, everybody understands that some days are busier than others. But that's not what they're saying. That's just me talking. So anyways, the mean is the better judge, because then even if you have some really good days and really bad days, you're still hitting $500 a day, hopefully, if you're doing a good job. Okay? Number 5, the chart shows the class marks on a test. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20 marks. Create a stem and leaf plot. Okay, back to a stem and leaf plot. All right, here we go with my stems and my leaves. So I've got 76, 78, 69, 76, 73, 76, 74, 66, 69, 85, 74, 66, 71, 76, 87, 96, 66, 98, 91, and 73. Okay? Now, you have to take this and make it into a good copy, because clearly 7, 6, 8, 9 is not in order, nor is any of this. So you need to take this, redo it, and put everything in order to create your proper stem and leaf. Okay, that's part A done. Pause the video, go do it. Part B, find the range, mode, median, and mean. Which value is hardest to read or calculate from the stem and leaf plot? Okay, so find the range. Once you get this ordered in your stem and leaf plot, the first number that's here is the lowest. The last number that's here is going to be the highest. Okay, once it's in order. Mine is not in order, but this is your first piece, this is your last piece. So you're going to take this and subtract it from that to get your range. To get the mode, you're going to find which piece of data repeats the most. Off the top of my head, I see 3 6s there. And I see 1, 2, 3, 4 6s there. So I'm going to guess that 76 is the mode, but I don't have it perfectly worked out, so I might be wrong. Median, once you have everything in order, the 20 pieces, count your leaves to make sure there's 20 so that you haven't missed anything. Right? And then you can take your fingers and walk in. 1, 2, 3. You can write them all in a line too, if that helps. You can figure out what would the middle number of 20 be. What am I looking at? Would it be 10 and 11? Because then I'd have 9 below it and 9 above it. So maybe you need to find the 10th and 11th number. If they match, that's an easy one. If they don't match, then you're going to have to figure out what's halfway between them. And the mean, so you're going to add it all up and divide by 20. Which value is the hardest to read or calculate from the stem and leaf plot? Well, it's not the mode, you can see that easily. It's not the range, that can be done easily, right? The median, you can pretty much count up the, find the middle numbers from the leaves. I would guess that the mean is the hardest, because you have to put your numbers all back together and add them all back up. But I don't think any of it's actually very hard. It's just that would be the hardest. Okay. Part C. Tom's mark was 76. Which one of the following statements that he told his parents was true? Explain using the mean, median, mode, or range. Now, I don't have the stem and leaf plot right in front of me. It is on the answer sheet, but so I did better than half the class. Was 76 better than half the class? So were there 10 people below him, is what you're asking. Is that true? So what method of central tendency or measure of central tendency did you use? I would say you're looking at the median so that you know where half the class is. Number 2, my grade is higher than the average. Well, the average, if you think about is the average the mean? Is his 76 equal, less, or more than the average? Or the same? Number 3, a lot of students had the same grade as me. Is that true? How many other kids had a 76? 4. Only 6 students got a better mark than me. Okay, so when you're on your stem and leaf plot and you find his 76, were there 6 students who got a better mark than him? And what are you using for that, right? I would guess you're using the median because the numbers are all in order. 76 was the most common mark. So there you go. Is 76 the mode? If it is, then he's correct. Okay, go answer that, come back to the second page. Okay, table shows the price for the same pair of shoes at 7 different stores. Anywhere from $81 to $86. Find the mean, median, and mode, right? So mean, just add them all up, divide by 6. Median, put them all in order. Find the middle number. Mode, which is the price that's repeated the most. Okay, pause the video, go do that. Store B claims its prices are lower than average. Which average could they use to make this statement true? Mean, median, or mode? So, considering that average is, this sort of common word for measures of central tendency. You can use mean, median, or mode for your average. Generally, people talk about it as the mean, but you could use any of those. So once you figured out the mean, median, and mode, store B's price is $85, right? Is that less than the mean? You have to tell me. Is it less than the mode? The mode is the most frequently occurring piece of data. Is it the median? When you lined it up, is it below the halfway point? Okay? So you need to figure out which one of those actually makes it true and why. Do you think the claim is misleading? Why? Yes, I think the claim is very misleading because store B is actually one of the most expensive. So they are not lower than average by most measures of central tendency. Okay, investigation. Consider the set 5, 5, 5, 5, 5. What are the mean, median, and mode? Well, you shouldn't even have to figure it out. Consider the set 4, 5, 5, 5, 6. Find the mean, median, and mode. Compare your answers to part A. Okay, you can do all that. Mean, median, mode. Okay, use the bead or blocks. So remember where the beads on the stick, where you had to move them to make them all the same, or the blocks where you had the mean marked, so you marked the spaces below and the spaces above. To explain why the answers in A or B are the same. Oh, look at that, I gave it away. Okay, so the way I chose to explain it is if I have my sticks, 1, 2, 3, 4, 5. And I have 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and my mean is here, right? I have one block sticking out and I have one missing bead there. So I take it from there, give it to there, everybody's at 5, and the mean is 5, okay? Create another set of 5 numbers where the mean, median, and mode are 5. So you got to remember that if there's a mode, that's the first thing I always look for. That helps me build my data set. It says the mean, median, and mode are 5. So that means I have to have 2 5s to make it the mode. I could have more 5s, but I have to have at least 2. And there can't be any other doubling of numbers, okay? So, and my 5s have to be in the middle so that they are also the median. So I need to add numbers on this side and on this side. But I have to have, if I'm picturing my missing blocks, I have to have as many missing on this side as I have extras on this side. So let's say we go 6, 7. So this has 1 extra block and this has 2 extra blocks. So, and I have 1, 2, 3, 4, and I need a 5 set of data. So I'm going to add a number here. But this is +3, so this has to be -3. So I'm going to make this a 2, right? Because that's 3 away from 5. So 5 and 5 is 10, 2 is 12, 12, 18, 25. 25 divided by 5 is 5. Okay, so my mean is right, my mode is right, and my median is right in the middle. Okay, now these numbers, there's lots of things you can do. There's not only one way it works. This could be like 112 and 200, and then you would just have to figure out how many extra blocks you have and take it away from that side. Now we would be into negative numbers here, right? But that's okay too. Nobody says we can't have negative numbers. You guys have learned about integers, not with me, but I assume with somebody. Okay, will the mean and median be the same or different in this set? 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Will the mean and median? Okay, median in the middle, so it's 5. Now, think about this. This is +1, and this is +1, and this is -1, and this is -1. So that means I've got extras to give over there, and it means our mean stays at 5. I think of this as like a scale. right? So I have +1 here and +1 here and 1 minus and 1 minus. So those all cancel each other out and I'm still left with 5 in the middle. Okay? Is there a mode? No, there's no mode. There's none of them that repeat. So, no mode. Use the bead and block method to explain why the mean and median are the same in the set 5, 5, 7, 8, 10. So they're telling us that the mean and median are the same. So let's assume it's going to be 5, right? Use the bead or block method. Okay, so 5 and 5 is 10, 25, 35. 35 divided by 5 is 7, okay? So our mean is 7. Our median is also 7. It's in the middle. So let's think about this as the scale, like I do in my head, okay? So the mean is 7. So 8 is +1, and 10 is +3. 7 to 5 is -2, 7 to 5 is -2. So on this side I have -4, and on this side I have +4. So that's why it's the same. Because the numbers on either side of the mean cancel each other out and leave you with the same mean. Okay, number 7, 8, 9. Whew, got to get through this. Find a data set, not all numbers equal, where the mean, median, and mode are the same. Okay, so again, we have to have something that repeats because we have a mode. I chose something easy because they add easily, so I chose my mode to be 10 and 10. Okay, now I need the median to also be 10, which means I need an equal number of pieces of data on either side to keep this in the middle, right? And if we're thinking about the scale, where 10 is here, this number and this number have to cancel each other out so that it stays the same. So we could make this 11 and this 9, +1, -1. Cancel each other out and I'm still left with 10. Okay? So mode was 10, median was 10, and mean is 10. Okay, find the mean, median, and mode of these sets. Set A, 2, 3, 4. That's A. B is 2, 3, 4, 5, 6. Okay, so mean, 2 and 3 is 5, is 9, divided by 3 is 3. Median, also 3, it's right in the middle. No mode, nothing. There is no mode. Okay, oh, we weren't even supposed to find the mode. So there you go, mean and median. Mean, 2, 3, 4, 4, 7, 9, 14, 20 divided by 5 is 4. The median is also 4, it's in the middle. Okay, move one data value from set A to set B. So we're going to move one data value. I like keeping it easy, so let's move the 2 over to there. So now we have 2, 2, 3, 4, 5, 6. Okay? Did the mean and median of each set increase, decrease, or stay the same? Okay, without doing any math, just think about this. The mean of 2, 3, 4 was 3, but I got rid of the lowest data value. I took that out, and that was pulling the mean down. So with the 2 gone, the mean can come up a bit. So 3 and 4 is 7, divided by 2 is 3.5. So the new mean would be 3.5 here. Okay, so the mean went up. Here, I added a low value piece of data, which means it's gonna drag the mean down. Right? So let's just do it just to make sure. 2 and 2 is 4, 7, 11, 16, 22, and 1, 2, 3, 4, 5, 6, divided by 6. Let's see, it's 3 gets me to 18 times, and then I've got 4 left, which is 2/3, so it's 3.67. Okay? So my mean came down because I added a low value piece of data. Okay, so that was part B. Part C, explain why the mean and median of set B cannot increase if a value from set A. Okay, so we have 2, 3, and 4 to choose from. The mean before we did anything was 4, which means to lift the mean up, I need some high value data. Set A does not have any high value data. The highest thing you can add is a 4, which best case scenario will keep it the same. It cannot pick it up because it's not greater than the mean that was already there. Okay? 9, when a soccer player moved from team A to team B. So there's 2 teams, A and B. The mean age of both teams increased. Give an example of data to show how this could happen. This is very much like the question we just did. So think about this. There's 2 teams. I move a player from one team to the other, and the mean age of both teams increased. Okay? So you know what? I did this wrong. The mean age of both teams increases. Okay, no I didn't. In my head I had it backwards. Okay, so let's see that these kids playing soccer, or whatever it is they're playing, are 5, 6, 7, right? These kids are 7, 8, and 9-year-olds, right? What if I took the low piece of data on this one and gave it over there where it would become a high piece of data? That would increase their mean age because I added a high value piece of data. On this side, I have removed a low piece of data, which means that it was holding this average down. Now that it's gone, it's like an elastic. It's going to spring up a little bit. So this team would increase by losing their youngest player. This team would increase by gaining their oldest player. Okay? Bonus, you have a set of 6 whole numbers. Some of them can be 0. Find the lowest possible sum of all the numbers if the set. All right, so I had to think really hard about this one. Okay, 6 numbers. We need 6 numbers. Median in the first one is 50, which means that 50 has to be in the middle. Okay, so we could have, but it's 6, which means that there won't be a number in the middle. It's going to be the middle of 2 numbers. So we have to have 2 50s and make that in the middle so that the median is there. Okay? Now we need the lowest possible sum. Okay? So we have to add a number here and balance it out with a number here. So why don't we make this 49 and this 51. And this 48, and this 52. 1, 2, 3, 4, 5, 6. Median is 50, which means the lowest, so 50 and 50 is 100, 49 and 51 is 100, 48 and 52 is 100. So the lowest possible sum is 300 as far as I can figure out. If you can do something better, I would love to hear it. Okay, B, mean is 500. Remember, mean is like a scale, right? So we need the mean to be 500. And we'll give it another 500. Now, let's go down 1 and up 1 to keep it the same. 499, 501. 498, 502. Right? So that means we've got 1,000 here, 1,000 here. 499 and 501 would make 1,000, and 498 and 5,002 would also make 1,000. So 1, 2, 3,000. 1, 2, 3, 4, 5, 6. So our mean is 500. So the lowest we could get is 3,000. Again, try it yourself. You can do it a different way. You know the thing with math is things can always be done more than one way. If you find a better way, teach me. Okay, and the last one, the mode is 5,000. Okay, so that means we have to, if it's a mode, it means that we have to have at least two 5,000s, right? And I believe it says some of the numbers can be 0 if you like, right? So what if we had, so our mode is 5,000, and what if we had, it doesn't say I can't have more than one number the same, right? You have a set of 6 whole numbers, some of them can be 0, find the lowest possible sum of the numbers. Okay, so okay, so we can't have more than 2 zeros because then that would become our mode. But what if we had 0, 0, and 1, right? Actually, mode doesn't even have to be balanced. It's just the most common piece of data. So what if it was 0, 0, no, can't even do that because we have two 5,000s. So what if it was 0, 1, 2, 3? Then our mode is still 5,000, and these are the lowest possible values we could give. So it would be 10,000 and 3, 4, 5, 6. 10,000 and 6 would be the lowest possible value. Okay? That's it for today. It was a long thinking one, but we got through it, and I'll see you tomorrow.